All right, pre-calculus, welcome to your quiz review video for section 4.5, really 4.5 to 4.6. We're only going to quiz on those two sections. All right, today we are brought to you in the classroom by literary sponsor, Can't Hurt Me. All right, we're getting close to the new year, new year, new you. Can't go wrong with Can't Hurt Me, followed by Viktor Frankl's Man's Search for Meaning. Shout out to SIUE and Laura Barr for being our respective college sponsor today and Healthy Bar sponsor. All right, here we go, folks. In this quiz review, 1 through 3, we're going to evaluate each. These should be very easy, as natural log e to the x is always whatever that exponent x is. So in this case, it's simply root 2. Natural log of e to the negative fourth is simply negative fourth. Then we have 2 to the log base 2 of 2/5 equals what, what. So we're going to set this up as an exponential, so it equals x. So 2 is actually the base, x is the answer, and this is actually the exponent. So if I put it in log form, you can probably have a guess as to what the answer is gonna be. All right, but I would rewrite this in log form, which again is weird because log's already there, but this is technically now exponential form. So I'm going to say log base 2 of my answer equals my exponent. Then I have log base 2 of x equals log base 2 of 2/5. X is 2/5. All right, here we are going to write as a sum or a difference. We're going to expand. All right, we're going to expand. Again, I put where it's okay to leave your answer. This can be a bit more challenging because sometimes you just don't know when to stop with it. All right, so here I clearly have division. All right, so I'm going to say log base 3 of my numerator minus log base 3 of my denominator. All right, then what we definitely have to do, I have a product here. So in the log world, multiplication means addition. Addition means multiplication. So I put a plus in between log base 3 of x plus log base 3 of y squared minus log base 3 of z, which is honestly okay. There. All right, that one's fine. You can also bring the exponent down, but you would get full credit for this right there. All right, I probably recommend doing 5 like this, okay? So you have a power to a power. You're going to multiply the powers. This is b to the 1/2. 1/2 times 4 is 2, and then 2 times 4 is 8. So honestly, you should do it like this. Then you have log base 2 of a to the 8th plus log base 2 of b squared, and that would be an appropriate answer. You can have 8 log base 2 of a plus 2 log base 2 of b. That's fine. Okay. So right here we have a product, so it's going to be log x squared plus log square root of 3, or x to the third plus 1, which honestly should suffice as an okay answer. You can also bring it down. Here I didn't do a good job. I would have to bring it down as well. Again, with the expanding, it can be hard to know when exactly to stop. Sometimes these are on the ACT, and then you get an answer, and you know, like, oh, I got to go a little further. But I would count this as okay. And then lastly, here's what we're doing. If everything is being squared, that means the top is being squared, the bottom is being squared. Okay, what I have here is I have division, so I'm going to write it as minus natural log of the numerator minus natural log of the denominator. And at this point, we are also fine, but you can bring the exponents down. You can bring the exponents down. So this, again, this first part is a fine answer. That second part, obviously, pretty good. So, you'll have like a few of those. All right. We can talk more about those in class. About like, where can I stop for my answer? Now, 8 through 11, these is going to be easy. You need to write it as a single log or natural log. All right, nothing out in front, so it's easy to tell when we can be done. In the log world, a number up top can be written as an exponent. All right, so this is 3 times 2, 6 power. 1/2 times 1/2 is a quarter. And in the log world, addition means multiplication. So log base 4 of x to the 6 times x to the 1/4 is x to the 6 over 4, x to the 3 over 2. All right, number 9 right here, natural log of 2x squared plus natural log of x to the third minus natural log of 4x to the fourth. And the log world, addition means multiplication. and then subtraction is division. All right. So it'd be like natural log of 2x to the 5th minus natural log of 4x to the 4th, and then we put them together as such. Highest power up top, and you got a 2 in the denominator. Natural log of x divided by 2. Really nice answer there. All right, next year in calculus, in your chapter 1, you're going to see questions like this. You're going to bring this power up, bring this power up, bring this power up. We have straight addition, which is straight multiplication. Power to power means I'm going to multiply the powers. Going to multiply the powers. Going to multiply the powers. Okay. And then I'm adding, so I'm multiplying. So that's means I'm going to add the exponents. X to the 10th. Y to the 6th. Let's go. All right. Number 11. A lot going on 11. So let's be careful. So first off, I actually want to do something better here. All right, so first off, I'm going to raise this. 4 times 1/2 is 2. I'm going to leave the minus 1/2 on the outside, and I'm going to combine, because I have addition, so it's going to be log base 2 of x to the 9th, right? Log base 2 of x to the 9th on that one. So we're actually going to come over here with it. Hopefully we get the same answer as what was emailed to you. But now I'm going to have log base 2 of x to the 4th minus log base 2 of x squared minus, right? So I'm going to bring that 1/2 power, bring it up. I'm going to do 9 times 1/2, which is 9 over 2. All right. Which means I'm going to do this first division. All right. It's going to give me log base 2 of x squared. Then it's going to be minus log base 2 of 9 over 2. All right. Well, this is going to be log base 2 of x squared. Log base 2 of 9 over 4. 9 over 4 is bigger than 2 by 5 over 2. We get the same answer. Log base 2, 1 over 5x to the 2nd. Maybe that a little nicer work there. Combine what's inside the parentheses first, and then raise it to the 1/2 power. I think it's a better idea than what I showed you in the answers. But we get the same answer. All right, here we go, folks. We are solving. Now, if you can't get the same base, like maybe you could on the first quiz, we want to attach natural logs. So 5 and 3, you're not going to find a common base. We're going to attach natural log to both sides, right? Which means that power comes on down. So I have x natural log 5 equals x plus 2 natural log 3. Got to do a little distribution. So x natural log 3 plus 2 natural log 3. Going to move this over, get the x's on the same side. X natural log 5 minus x natural log 3 equals natural log 9. We factor out the x we have in common. X times natural log 5 minus natural log 3 equals natural log 9. We'll divide by what's attached to x. That's a complicated looking answer, but that is in fact exact answer. There's no decimals. Here we are, number 3. 3 is the base, 2 is the exponent, x minus 2 in the square root is the answer. So 9 is equal to the square root of x minus 2. I'm going to square both sides. 81 is equal to x minus 2. X is equal to 83. All right, take a look at number 8. Now we talked, about 14. We talked about 14 and 15 in class yesterday. All right, so you can get the same bases here. 8 is 2 to the 3rd. 4 is 2 squared, and obviously 2 is 2 there. All right, so we're going to have a power to power. We multiply those powers. And in the log, or when I'm multiplying with the same base, I add the exponents. Okay, so then I have 2x squared plus 5x is equal to 3. Then I factor that. I get 2x minus 1, x plus 3 equals 0. So I get x is 1/2, x equals negative 3. You can have a negative exponent as a power. Okay, just in a log, you can't have a negative base or a negative answer. You can't have log negative 3. You can't have log of natural log of negative 2 or 0. All right, it was 15. That was a bit interesting here. Okay, so I'm just rearranging it. Then, so like this is one way of doing it. I think in class yesterday, we did it another way, right? I think you might actually like that way better. All right, so we got the same answer, but we have 2 to the x times 5 is equal to 10 to the x. What we're going to do is divide both sides by 2 to the x power. Then we have 5 is equal to, if they're both raised to the x power, I can just put that x on top like that. All right, and 10 over 2 is 5. So now I have 5 to the first equals 5 to the x. X would be 1. X would be 1. That's just another way of doing it there on 15. We will try one of those in class together. Okay, then we have 16. Log base 6 of x plus 3 plus log base 6 of x plus 4 equals 1. In the log world, addition means multiplication, so I'm going to FOIL those together. X plus 3 times x plus 4, that's x squared plus 7x plus 12. 6 to the first is equal to x squared plus 7x plus 12. We're going to subtract 6 from both sides. We're going to get 0 is equal to x squared plus 7x plus 6. 1 multiplies to 6 and adds to 7. 6 and 1. So x equals 6 and x equals negative 1. But let's be careful, folks. If I plug negative 6 in for x right there and right there, I get log base 6 of a negative number, which is undefined. So negative 6 is extraneous. Negative 1 is the only right solution. You can only report negative 1 for full credit. And let's end it here, these questions. E to the 1 minus x is equal to 5. We're going to attach natural log to both sides. Natural log of e to the whatever is simply that whatever. So 1 minus x is equal to natural log 5. What I did, because that's a negative, I moved it over while subtracting natural log 5. So 1 minus natural log 5 is x. All right, here's 18. 18, we're going to subtract 8 from both sides. Divide by negative 2. We get e to the negative x is equal to 2. I'm going to attach natural log to both sides. I get negative x is equal to natural log 2, so x is the opposite of natural log 2. You can also say natural log of 2 to the negative first, which is also natural log 1/2. That's pretty nifty, but the opposite of natural log 2 is going to get you full credit, I promise. All right, 17 is pretty interesting here, guys. In 17, we're going to attach natural log to both sides, right? We can't get 7 and e to be the same base. But take a look at this. Natural log of e to the x is simply x. X comes on down, all right? But I have x on the other side, so I got to do a little distribution. Okay, so I'm going to then move that x, natural log 7 to the other side. I'm going to factor out the x we have in common, leaving me with 1 minus natural log 7, and that's what goes in my denominator. Yes, 3 natural log 7 is natural log of 7 to the third. You can say natural log of 343 over 1 minus natural log 7. That works. That is not necessary. All right, log of blank equals log of blank. You simply set those blanks equal to each other. This will not factor. Got to use the quadratic formula. Get 1 plus or minus root 13 over 2. Normally, we would probably think the negative version isn't going to work, but 1 minus root 13, which is, gosh, a negative 2 point something divided by 2, it's still going to be positive. And if you square anything, that's always going to be positive, and you're going to add 3. So both of them actually work. All right. And here, folks, number 21. Number 21. In the log world, addition means multiplication. So I'm going to take x minus 4, multiply it by x plus 4. And that's going to give me x squared minus 16. So 2 to the third power is equal to x squared minus 16. 8 is equal to x squared minus 16. 24 is equal to x squared. Now, yes, last year you would have said plus or minus square root of 24, plus or minus 2 root 6, but you can't have a negative in there. All right. Can't have log of a negative number, that is. So the only answer that you can report is 2 root 6. All right, so that's what your quiz is going to look like. This is Yak Math Videos signing out.